Zytron provides a set of precompiled contracts to reduce the gas cost for users using L3. These precompiled contracts are all related to ZK. At the same time, relevant SDKs will also be provided. You can check the documentation to learn about the SDK and precompiled functions. A total of 5 precompiled functions are provided at different addresses. Anemoy is a ZK-friendly hash function. ED on BN256 is an elliptic curve function that provides elliptic curve point addition and scalar multiplication. Matchmaking is a ZK tool for PvP that can generate random numbers fairly among multiple players. Shuffle is a privacy shuffle algorithm using ZK. These functions are implemented as stateless precompiled contracts, which are equivalent to pure functions. Therefore, static call is used to call them directly, and a-by encode is used to construct parameters. Anemoy and ED on BN254 are both in gZKm. Shuffle is in ZShuffle crate. Matchmaking is in ZMatchmaking crate. At the same time, the SDK provided by Zytron is written in pure Rust. It can be used as a Rust SDK or compiled into WebAssembly to run in the browser. First, 2 Edwards-affine points are randomly generated. Then the x and y values of the 2 points are respectively encoded using Solidity ABI. We compile and run the code to get the input for calling the precompiled contract. Here we use cast instead of contract call test. You can also use the Solidity to call precompiled contract directly for testing. Use ABI encode to encode call parameters in the Solidity. Send the generated ABI encoded data by Rust to the precompiled contract address. You can see the return point from precompiled contract. This point is also encoded using Solidity ABI. Using ABI decoding, we can see that x and y Similar to ED on BN256 add, first randomly generate a scalar value and a point value. Perform Solidity ABI encode in the order of scalar, point x, and point y. As described in the document, we can call the contract directly in Solidity. Use static call to call the precompiled contract and get the x and y of the point. We still use cast for call testing and send the generated ABI encoded data to the precompiled contract address. Based on the description in the document, we can also decode the x and y values of the point. Anemoy is a ZK-friendly hash function. It can accept data of any length. The data needs to be divided into 32-byte groups. Here, 3 scalars are generated as input. Use them in order to perform solidity encoding. Similarly, we can use the method in the document to call this method in Solidity. Encode a bytes32 array as the input of the precompiled contract. We still use cast call to simulate the contract call test. The data type returned here is bytes32, and we can use ABI decode to parse the hash value. Matchmaking is a ZK tool used in PvP, which can generate random numbers fairly among multiple players. Since ZK proof needs to be generated, and the size of the proof is large, we no longer use cast simulation, but directly use Rust code to send requests to the node. Don't worry, the SDK here does not involve any network operations. You can use WebAssembly to build proofs locally or in the browser. Here is an explanation of how to pass parameters to precompiled contracts. Verifier params is generated by getVerifierParameters method. Inputs is number of all players. Outputs is generated by prove matchmaking function. This function will build proof also. Commitment is the hash of committed seed. Committed seed must be keep private in player local device. The hash function must be anemoy. Random number is a random scalar number. Difference with committed seed, it a public value. Proof is generated with outputs. Finally, we will use document's order of parameters to build ABI encoded data. For now, we will build ZK proof and submit it to Zytron RPC. This step will waste many time. The time of proof generated is decided by your device performance. We can find that calling the precompiled contract here requires a relatively large amount of data. All data that needs to be passed to the precompiled contract is 2,000 bytes long. This precompiled contract will only return true or false based on the verification result of ZK proof. Shuffle is a ZK-based shuffling algorithm that can ensure fairness and randomness of shuffling, and it will not leak the cards. This algorithm supports custom cards. Supports masking, shuffling, and revealing of cards, and can verify these actions. Here, we explain the relevant parameters and related logic. First, everyone who participates in the shuffle needs to create their own key pair and calculate the joint public key of the participants. Everyone here can mask their own cards and pass the pie to other participants. Other participants can verify it locally. Next, we can build verifier params. It needs to be generated based on all participants' joint key. Anyone can call prove shuffle to perform a shuffle operation and encode the results before and after the shuffle. The shuffle process can then be verified through a precompiled contract. We start the proofing process and submit data to the chain to verify the shuffle process. Compared with matchmaking, the shuffle algorithm has a larger amount of calculation. Therefore, we directly submit proof-related data in the code. Of course, Shuffle SDK is also an SDK that does not require network access. It can be executed locally and in the browser. The exact time it takes to generate depends on your device. The verification result is expressed as true or false. Go to the Zytron Faucet official website, faucet.zytron.io. Open your MetaMask wallet, copy the wallet address where you want to receive the test token, paste the address into the address field on the page, then click the Claim button. Once a pop-up window appears, the claim is successful. First, go to the Zytron Bridge official website, zytron-testnetbridge.zypher.game. When using it for the first time, the system will automatically configure the RPC for the B2 test network in your MetaMask wallet. You just need to click Approve to authorize the configuration. Once configured, click Switch Network to switch to the corresponding network and proceed to the next step. Next, we enter the deposit tutorial. The page will display the assets in your wallet address on the B2 network. Enter the amount of GP tokens you want to deposit in the input field, then click the Deposit button. The system will transfer the specified amount to the Zytron L3 chain. Click the wallet address at the top right corner of the page. A drop-down window will appear, and select View Deposit. The system will automatically redirect to the deposit history page, where you can view the status of your current deposit record. Return to the Zytron Bridge official website, click the tab to switch to the Withdraw page, and select and add Zytron B2 test network. Then switch from the original B2 test network to the Zytron B2 test network. Enter the amount of GP tokens you want to withdraw in the input field. Then click the Withdraw button. The system will transfer the specified amount back to the B2 test chain. Click the wallet address at the top right corner of the page. A drop-down window will appear, and select View Withdrawals. The system will automatically redirect to the Withdraw History page, where you can view the status of your current withdrawal record.